Hello students, welcome to lecture series of Mathematics 1. I am Hitesh Manglani, Assistant Professor at LJ Institute of Engineering and Technology. So today we will discuss topic that is Fourier series of function of period 2l. So first of all, what is Fourier series? So Fourier series is used for the analysis of periodic functions. And Fourier series is summation of infinite terms of sine and cosine. So before starting Fourier series, first of all we will discuss Dirichlet's condition for representation by a Fourier series. So what are Dirichlet's conditions? So the Fourier series of function f of x exists only if the following conditions are satisfied. So first condition is f of x is periodic. That is f of x is equal to f of x plus 2l, where 2l is the period of the function f of x. This is the first condition. What is second condition? F of x and its integrals are finite and single value. Third condition is f of x has a finite number of discontinuities. That is, f of x is a piecewise continuous in the interval c to c plus 2l. And fourth condition is f of x has a finite number of maxima and minima. So these four conditions are called Dirichlet's conditions. And if these four conditions are satisfied, then and then we can find the Fourier series of the function f of x. Now let us discuss Fourier series of function of period 2l. So suppose f of x is a periodic function with period 2l in the interval c to c plus 2l, then the Fourier series f of x is given by f of x is equal to a0 divided by 2 plus sigma, where n varies from 1 to infinite, an cos n pi x by l, plus sigma, where n varies from 1 to infinite, bn sin n pi x divided by l. Now here a0 is given by 1 divided by l integration from c to c plus 2l f of x dx. So this is a0. Now an is given by 1 divided by l integration of c to c plus 2l f of x into cos n pi x divided by l dx. And what is bn? Bn is given by 1 divided by l integration from c to c plus 2l f of x into sin n pi x divided by l dx. So this is how we can find out value of a0, an and bn. Now we will discuss examples related to Fourier series. So let us discuss first example, that is find the Fourier series of function f of x is equal to x square in the interval 0 to 2 pi, and hence reduce that pi square by 12 is equal to 1 divided by 1 square minus 1 divided by 2 square plus 1 divided by 3 square minus so on. So in this example, we will have to find out the Fourier series of the function x square in the interval 0 to 2 pi. So first of all, here we will find out the value of L. So comparing the interval 0 to 2 pi with 0 to 2l. So if we compare 0 to 2 pi with 0 to 2l, then 2l is equal to 2 pi. Therefore, value of L is pi. Now, as we have discussed earlier, the Fourier series of function with period 2l is given by f of x is equal to a0 divided by 2 plus sigma n equal to 1 to infinite an cos n pi x divided by l plus sigma n equal to 1 to infinite bn sin n pi x divided by l. Now here value of L is pi, so this will be a0 divided by 2 plus sigma n equal to 1 to infinite an cos n pi x divided by pi. So pi cancel out, so here it will be nx plus sigma n equal to 1 to infinite Pn sin n pi x divided by pi. So again pi cancel out, so there it will be nx. So this is Fourier series of function with period 2 pi. Now we will find the value of a0. So a0 is given by 1 divided by L integration from c to c plus 2L f of x dx. So here value of n is pi. So we will replace L by pi. So here it will be 1 divided by pi integration from 0 to 2 pi, because here we will have to find the Fourier series of function in the interval 0 to 2 pi. Therefore limit will be from 0 to 2 pi and function is x square. So integration from 0 to 2 pi x square dx. Now what is integration of x square with respect to x? So we know the formula integration of x raised to n is x raised to n plus 1 divided by n plus 1. So by that formula integration of x square will be x cube divided by 3. So here it will be 1 divided by pi into x cube divided by 3 and limit will be from 0 to 2 pi. Now here first of all we will replace x by 2 pi, that is upper limit, minus x by 0, that is lower limit. So here replacing x by 2 pi, so it will be 1 divided by 3 pi in bracket 8 pi cube, because 2 pi whole raised to cube. So it will be 8 pi cube minus 0, because lower limit is 0. So if we simplify this result, then it will be 8 pi square divided by 3, because pi cube divided by pi, so it will be pi square. So value of a0 is 8 pi square divided by 3. Now we will find out value of an. So as we have discussed earlier, an is given by 1 divided by n integration from c to c plus 2l f of x into cos n pi x divided by L dx. Now value of n in this example is pi. So we will replace n by pi. So it will be 1 divided by pi integration 0 to 2 pi, because here we are finding the Fourier series of function in the interval 0 to 2 pi. Therefore limit will be from 0 to 2 pi f of x into cos nx dx, because here n pi x divided by pi, so pi cancel out, so here it will be x. So what is f of x? It is x square, so this will be 1 divided by pi integration 0 to 2 pi x square into cos nx dx. Now here there are two functions. First function is x square and second function is cos nx. So here we will use the Bernoulli's formula, and before using Bernoulli's formula we will have to identify the function whose successive differentiation is 0. So from these two functions whose successive differentiation is 0, that is x square. So we will choose x square first. So x square is the first function. So here first function will be as it is, then we will take integration of second function, then minus derivative of first function and again integration of second function. So this way we will use the Bernoulli's formula. So here first of all 1 divided by pi will be as it is. Here first function is x square, so it will be as it is. Then integration of second function. So second function is cos nx. And integration of cos theta is sin theta. So here it will be sin nx divided by n, because the coefficient of x is n. Then minus, now we will take derivative of first function. So here first function is x square, so derivative of x square will be 2x. And here we will take integration of sin nx divided by n. So integration of sin nx divided by n will be, what is integration of sin theta? That is minus cos theta. So here it will be minus cos nx divided by n square, because here coefficient of x is n and here it is already n. So n into n, it will be n square. Now plus we will take derivative of 2x. So derivative of 2x with respect to x will be 2, because derivative of x is 1. And now we will take integration of minus cos nx divided by n square. So what is the integration of cos nx? It is sin nx divided by n. So n into n square, so it will be n. So this will be minus sin nx divided by n cube. Now again, if we go further, then derivative of 2 will be 0. Therefore, no need to go further. So now we will apply the limits, that is 0 to 2 pi. So first of all, now we will replace x by 2 pi, then minus, then lower limit will be 0. So for that we will replace x by 0. So here first of all we will replace x by 2 pi, then minus, replace x by 0. Because first of all we will apply the upper limit, then minus lower limit. So here if we replace x by 2 pi, then here it will be sin 2n pi, and value of sin 2n pi is 0. And here it will be cos 2n pi, and value of cos 2n pi is 1. And here again sin 2n pi, and value of sin 2n pi is 0. So for the upper limit, here it will be 2 into 2 pi, so it will be 4 pi, and minus minus plus. So 4 pi into cos 2n pi, and value of cos 2n pi is 1. So it will be 4 pi into 1 divided by n square. So it will be 4 pi divided by n square. So this is the answer of upper limit. So if we apply the lower limit, so for that replacing x by 0. So here if we replace x by 0, so this will be 0. And here if we replace x by 0, so second term will be 0. And here sin 0 will be 0. So lower limit will be 0. So here it will be 1 divided by pi into 4 pi into cos 2n pi divided by n square. And value of cos 2n pi is 1, so it will be 4 pi divided by n square into 1 divided by pi. So if we simplify this result, then it will be 4 divided by n square, because pi cancel out. Now we will find out Bn. So Bn is given by 1 divided by L integration from c to c plus 2l f of x into sin n pi x divided by L into dx. Now here in this example, value of L is pi. So here we will replace L by pi. So it will be 1 divided by pi integration 0 to 2 pi f of x sin nx dx, because here pi divided by pi, so it will be cancelled out. So what is f of x? F of x is x square, and here limit is 0 to 2 pi, because we are finding the Fourier series of function in the interval 0 to 2 pi. So it will be 1 divided by pi integration 0 to 2 pi x square sin nx dx. Now here again, as you can see that there are two functions. First function is x square, second function is sin nx. So here we will use the Bernoulli's formula. So here first of all we will have to choose the function such that its successive derivative is 0. So here we will choose x square because its successive derivative is 0. So here 1 divided by pi in bracket, first of all x square will be as it is, and we will integrate sin nx. So integration of sin nx, so integration of sin theta is minus cos theta. So here it will be minus cos nx divided by n, because here coefficient of x is n. Then minus, now we will take derivative of x square. So derivative of x square is 2x. And now we will integrate minus cos nx divided by n. So what is the integration of cos theta? That is sin theta. So here integration of cos nx will be sin nx divided by n. But here already it is n. So n into n will be n square. So here it will be minus sin nx divided by n square. Plus, now we will take derivative of 2x. So derivative of 2x with respect to x will be 2, because derivative of x is 1. Now we will integrate this bracket, that is minus sin nx divided by n square. So what is integration of sin nx? It will be minus cos nx divided by n. But here it is n square, so n square into n will be n cube, and minus minus will be plus. So here it will be cos nx divided by n cube. Now if we go further, then derivative of 2 will be 0. So no need to go further, so we will apply the limits. Limits are from 0 to 2 pi. So here first of all, we will replace x by 2 pi, that is upper limit, then minus we will replace x by 0, that is lower limit. So here if we replace x by 2 pi, then here it will be 2 pi whole square, so it will be 4 pi square. So 1 divided by pi into 4 pi square into minus cos 2n pi divided by n, because I am replacing x by 2 pi. Then here, if we replace here x by 2 pi, then here it will be sin 2n pi, and value of sin 2n pi is 0. Therefore, no need to write out this term. And here, if we replace x by 2 pi, then it will be 2 into cos 2n pi divided by n cube. So now we will replace x by 0, that is lower limit. So if we replace x by 0, so first term will be 0. Same way, if we replace x by 0, so second term will be 0. Now third term will be minus 2 into cos 0 divided by n cube. Here it is minus because of lower limit. So here we know that value of cos 2 and pi is 1 and value of cos 0 is 1. So it will be 1 by pi minus 4 pi square divided by n plus 2 divided by n cube minus 2 divided by n cube. So these two terms will be cancelled out. So finally it will be minus 4 pi square divided by n. So now if we simplify this result, then it will be minus 4 pi divided by n, because pi square divided by pi it will be pi. So this is the answer of Bn. Now here, as we have to find out the Fourier series of the function, so Fourier series of function is given by f of x is equal to a0 divided by 2 plus sigma n equal to 1 to infinite a n cos nx plus sigma n equal to 1 to infinite b n sin nx. So here we will put the value of a0, a n and b n. So it will be 4 pi square divided by 3, because value of a0 is 8 pi square divided by 3. So a0 by 2 will be 4 pi square divided by 3 plus 4 sigma n equal to 1 to infinite 1 divided by n square cos nx, because value of an is 4 divided by n square. Then minus 4 pi sigma n equal to 1 to infinite 1 divided by n into sin nx, because value of bn is minus 4 pi divided by n. So here f of x is x square, therefore x square is equal to 4 pi square divided by 3 plus 4 into sigma n equal to 1 to infinite 1 divided by n square into cos nx minus 4 pi into sigma n equal to 1 to infinite 1 divided by n into sin n. So this is the Fourier series of function x square in the interval 0 to 2 pi. Now here we will have to prove this result, that pi square divided by 12 is equal to 1 divided by 1 square minus 1 divided by 2 square plus 1 divided by 3 square. So for that we will put x is equal to pi in this equation. So if we put x equal to pi in this equation, then it will be pi square is equal to 4 pi square divided by 3 plus 4 into sigma n equal to 1 to infinite 1 divided by n square. Then here it will be cos n pi, and value of cos n pi is minus 1 raised to n. So here it will be minus 1 raised to n, and here it will be sin n pi, and value of sin n pi is 0. Therefore no need to write out this term. So here it will be pi square is equal to 4 pi square divided by 3 plus 4 into sigma n equal to 1 to infinite 1 divided by n square into minus 1 raised to n. So if we simplify this result, then it will be pi square minus 4 pi square divided by 3 is equal to 4 in bracket. Now here we will put different values of n starting from 1. So first of all we will replace n by 1. So here minus 1 raised to 1 divided by 1 square. So minus 1 raised to 1 will be minus 1 divided by 1 square. So first term will be minus 1 divided by 1 square. For second term we will put n is equal to 2 in this result. So minus 1 whole square divided by 2 square. So minus 1 whole square will be plus 1 divided by 2 square. So second term will be 1 divided by 2 square. Now for third term we will put n is equal to 3 in this result. So minus 1 cube divided by 3 square. So minus 1 cube is negative, that is minus 1 divided by 3 square plus so on. So there will be alternate sign. So if we simplify this by taking LCM, then it will be 3 pi square minus 4 pi square whole divided by 3. So it will be minus pi square by 3 is equal to 4 in bracket minus 1 divided by 1 square plus 1 divided by 2 square minus 1 divided by 3 square plus so on. So if we simplify this result, then it will be minus pi square divided by 12, because 3 into 4 will be 12, is equal to minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square plus so on. Now taking minus common from both sides, so minus minus will be cancelled out, so it will be pi square by 12 is equal to 1 divided by 1 square minus 1 divided by 2 square plus 1 divided by 3 square minus so on. So in today's lecture we have discussed what is Fourier series and Dirichlet's conditions and example related to Fourier series. Thank you for watching this video. I will see you in the next lecture.